want to talk about, Zach, I want to make sure I get these equations in. I want to make sure I talk about the pendulum. You know, man, I'm just fired up about this video. You're not filming yet, are you?
No, I'm still on the camera.
All right.
Pictures.
Okay, just let me know when you're ready to go.
Oh wait, what's the red? Oh.
All right, we're ready for pendulums. Okay, now with pendulums, they're awesome. They're pretty cool. We've seen them throughout our lives. You know, if you go to hang out at the playground, you see pendulums. Okay, that's all a swing is. It's just a fancy, fun pendulum. Okay, so we got to talk about some things that are going to make pendulums handy in life. When you would use them, when you wouldn't use them. You'll see those things actually when you start doing labs. But today I just kind of want to do just basically what the equation's about, and maybe some things that are going to help you through some of the problems that you have on your web assignment. Okay, so the equation is up here. It's the period equals 2 pi radical L over G. Now, John, that's an L in there, not a 1. Okay, you'll have problems with your problems if you put a 1 in there. Bad news. So I've written it in cursive so it looks a little bit more like an L, and that's going to be representing our length. Okay, G is our gravity. Now gravity on Earth is 9.8 meters per second squared. If you go to another planet, if you go someplace else where gravity changes, then you'll use that. All right, T. T represents our period. Okay, so how long it takes for one full swing. The inverse of that is our frequency. So 1 over T equals frequency. That's something you're going to start seeing. You're going to start seeing it more and more often throughout the class. So the more frequently it happens, the shorter our period is, or the less our period is. Excuse me. All right. So I've drawn a crude pendulum up here. I know my RT skills are not all that good. But let's take a look here. Some other things that are going to help us. Okay, a lot of times they'll talk about tension. You have a tension in the wire. Okay, that's just another term for our force. That's our weight force. Okay, this pendulum ball, this bob, when it's out there, it's got a force due to gravity. And when it's pushing down, it's pulling. That force is going to be transferred through the wire or through the rod, whatever we have there. Okay. Now it's going to form an angle with what it wants to do. Okay, this little area down here where it's straight down, that's called our equilibrium position. We need to know those things. Okay, that's going to help us generally with how long the pendulum is. Okay, there's going to be later on where we're going to have to know exactly how long the pendulum is. Okay, it's going to fit into our length equation. Those things are important. When we pull it back, okay, that's our amplitude. How far it goes back. That's amplitude. Just like when we're doing waves, the up and the down, how far away it is from the middle point is our amplitude. Now, if I just pull this straight back here and let go of it, in a perfect world, in things where we don't have air resistance, where we don't have anything that's going to cause friction, this should come right back to where it started. Unfortunately, we don't live in a world like that, and we live in a world that has air resistance. We live in a world that has friction, where we have friction up here. And so ultimately what's going to happen is it's going to come short of where it started. Okay, that's why I could take a pendulum, I could hold it up to my nose, let go, and it's not going to even threaten to hit me in the face. Now, next week, we're going to try this, Mr. Larson. I'm going to get you up there, and we're going to actually try this with a bowling ball. So come into class, be ready to get the bowling ball experiment. It's going to be awesome. I got the gnat in front of my face. Okay, so we have this. This is just a basic pendulum. We see these all the time. Clocks. Like I said, swing sets. So let's talk about a swing set. How can I get this to be going from here to maybe get it pushed out a little bit more energy? That's a thing called mechanical resonance. Okay, resonance is when I am applying a force to make it go even higher, to make my amplitude larger. So if you go on, you've ever been on a swing, when you pump your arms and drive your feet, that's an example of mechanical resonance. If you just pump your arms and legs wild or willy-nilly, just all over the place, you're not going to drive the swing. But as you pull back, if you drive your feet when you're at that high point, you're now going to push through. You're applying mechanical resonance. you're hitting the wavelength right at the right point, or you're hitting the pendulum swing at the right point. All right, hope this is going to help you out with your pendulums. We will have 2 labs next week that are going to help us determine how length and how gravity are going to affect a pendulum. But until then, have a good weekend.